Good morning all. Myself M. Temuri, Assistant Professor of Department EEE, and here I am just going to give up a description on design of electrical machine, and what we are going to see specifically in that, in the sense we are going to see about classifications of design problems and types of magnetic circuit. First thing, you want to know about what is electrical machine, and meanwhile you have your classification of that internally to be coined as stationary and dynamic. It can also be called as static and dynamic, in the sense it also can be coined as rotating. What about the example that is getting falling under your static category, in the sense it is transformer, and the machine that is falling under the category of dynamic, it is motor and generator. And we have the transformer to be in one line description. The operation of that one is to convert one voltage to other level of voltage by just maintaining your frequency as constant value. And meanwhile, in case of your motor and generator, we have your electrical energy conversion to be happening, in which motor you have your electrical energy is being converted into mechanical energy, and in case of generator you have the conversion of mechanical energy to be got out as electrical output. Okay, and how do you have this conversion to be happening? It just takes place in the place of a magnetic field. Okay, and you have a question about what is your magnetic field and how it is being produced. Actually, it is being produced by your electromagnets, which is being incorporated once you are just placing up your design consideration. And moreover, in order to just produce your magnetic field, it requires the arrangement of core and windings. Okay, and this winding takes up different names once it is being placed under the category of machine that is under static or rotating. Okay, and that is, for example, let me say about your winding. In case of transformer, you have two windings to be placed in your transformer core, that is primary winding and secondary winding. Whereas the same winding only, once it is being placed under your dynamic condition, that is being called as your stator winding and rotor winding. And moreover, you want to be with the conclusion about this winding to produce your magnetic field, in the sense you are in need of two winding setup in order to produce your magnetic field. And on what basis this magnetic field is being created and to have your machine to be operated, in the sense it just works with the principle of Faraday's law of electromagnetic induction. Okay, the next thing is, we'll just get into the topic of classifications of design problem. Majorly, you have your design to be fall under four categories, that is electromagnetic design, mechanical design, thermal design, and dielectric design. You check into the classification of electrical machine as static and dynamic, where you have your transformer and motor generator to be the example of those categories, right? We're just going to describe, we're just going to give up the major parts of these machines, that is transformer, motor, and generator. What are the parts that is getting falling under these four categories of design? That is your classifications of design problem. Okay, for example, if you are just constructing a building, in the sense you have your major work to be got out by your civil engineer, right? And those things will be taken up by your civil people, and for your electrical work you will be just calling up your electrician, right? And meanwhile, similarly, you have your classifications of design problems based on the parts that you are assembling in your machine once you are being constructing it. Okay, and here the electromagnetic design, in the sense we are just categorizing those designs under the classification of static and dynamic again. And what are the parts that is getting falling under this electromagnetic design, in the sense in case of your transformer, once you are seeing now, you have your core and winding to be falling under your static. Okay, and in case of dynamic, you have your winding setup that is being coined as stator winding and rotor winding, that is getting into your dynamic category once you are just choosing your electromagnetic design, that is design of stator and rotor core. Okay, and in turn it also can be given as stator and rotor windings also. And next thing is mechanical design. Once you are just taking up again with the classification of static and dynamic, you have your transformer tank is considered under your mechanical design, and for your motor and generator you are just taking up your frame, that is your outer enclosure, and also your shaft bearings. Okay, And next thing, once you're just taking up your thermal consideration, thermal classifications of design, again it is being categorized into two things, that is static and dynamic. In case of static, the parts that is, in case of transformer, the part that is allowed under your thermal is cooling tubes, and in case of motor and generator, you can just give up the name called cooling ducts, okay. And once you're just making up the construction of large machine, we can use your cooling agents, and normally it can also be air or else it can also be H2. What that air will be allowed to circulate into your ducts and air gap in order to just make your heat dissipation that is being developed under your operation, okay. And the fourth classification is your dielectric medium. In this case, the construction of your electrical machine takes up the major consideration is your placing of insulation, right? And the placing of insulation just gets fall under your dielectric here. And there only you will not be just given up with the internal classification of static and dynamic. In both these category, you are just choosing up your insulator to be given as for your dielectric design problem. And here it is being, what is the purpose of using your dielectric? In the sense, it is mainly used to insulate one conductor from other conductor, and also you just insulate your winding from your internal core, okay. And normally the purpose of using your insulation is mainly focused with the point in order to just withstand your voltage stresses that is being developed unexpectedly under your machine operation condition, okay. And the last point is, you want to just note down, once you are just making up your dielectric failure in a machine, definitely you will not be just having up your satisfied operation to be got out from your machine, okay. And that is, you have your breakdown of dielectric material which will result in your failure in operation. And moreover, the main usage of this dielectric is to withstand your temperature that is being developed in your machine, okay. And the next thing is, we will get into your circuits types, and that is, normally what is called a circuit, where once you are just making up your connection of electrical or else electronics devices to be connected together in order to perform a particular operation. That is your general definition for circuit. Once you just give up an input, it processes and just gives up your required output. That circuit can be designed according to your application and wherever you are just going to use it, okay. And general, you have your circuit to be got out under two things. One is electric circuit, the other one is your magnetic circuit. One is electric circuit, the other one is your magnetic circuit. And in case of your electric circuit and magnetic circuit, you have your parameters to be described, and therefore we can just categorize into your similarities and dissimilarities to be. And you see here, the similarities to be pointed out. The first thing that is being considered under your electric circuit is your EMF, okay, electromagnetic force. Whereas in case of magnetic circuit, it is being called as magnetomotive force. And normally EMF, what will do? It will just makes your current to circulate in your closed path. That is, the circuit in general, it is called as your closed path, which will allow the flow of electrons, okay. That is called as your electric circuit. Whereas in case of magnetic circuit, MMF, that is magnetomotive force, what it will be doing in the sense, it will create the flux which is being assembled in your closed path, okay. And you have your EMF to be allowed, EMF is being developed, which will just makes your current to get into your circuit, that is called as your closed path, and that current is being mainly opposed by a parameter of your circuit which is being called as your resistance. Whereas in case of magnetic circuit, that flux opposition is being coined as reluctance, okay. And to describe your similarities of electric circuit, you can say that the path of current that is flowing into a circuit is called as electric, and the path of flux that is getting to your closed path is called as your magnetic circuit. Moreover, you can just see the definition or formula that is being described in your screen as resistance is being given as rho L divided by A. Rho L is nothing but the resistivity, and L is nothing but the length of the material, and A is nothing but the area. And whereas you have your S, that is reluctance, is being given as your formula S is equal to L divided by mu A. And you have your description of your current formula, that is I is equal to V by R. And you see, I is nothing but the current. What is being coined with the same parameter in case of a magnetic circuit, I is nothing but compared with flux phi, and V in case of electric circuit, that is voltage, EMF is being compared with your magnetomotive force MMF, and therefore in case of your replacing your voltage we can write as MMF. In your denominator you can just write in place of resistance as reluctance. Okay, these are the 4 points that you want to be in with the thing that just falling under the similarities of electric and magnetic circuit. In case of dissimilarities, you have only 3 things, that is the current flows in your circuit. Actually the current is, the flow of electrons is said to be happening in your electric circuit, whereas in case of magnetic circuit actual flux is being assumed to flow. There is a major difference between these two circuits. Okay, the current is allowed to flow in a electric circuit, and whereas in case of magnetic the flux is being assumed to flow in it. Okay, and the next thing is, when you're just making up your current to flow in your closed path, actually the energy is being spent continuously. But in case of magnetic circuit, the energy is being required to create your magnetic flux, but it is not required to maintain through your circuit until you are just completing your operation. And the last foremost important point is, the resistance that is being offered by your electric circuit is mainly, the noted thing is, it is independent of the strength of current that is allowed to flow in your electric circuit. Whereas in case of magnetic circuit, the reluctance, that is the opposition of flux, that is called as reluctance, the property that is being got out in a magnetic circuit, it is mainly dependent on the total flux that is being present in your magnetic circuit at that instant. Okay, these are the points that is getting fall under the electric circuit and magnetic circuit, considered with your similarities and dissimilarities. Once you are just writing up your points by discriminating both your circuits, you should not make your dissimilarities points to be falling under similarities point. Be careful once you are just writing up the points to be noted under similarities and dissimilarities of these two circuits. Okay, the next thing what we are going to see is, how do you just create your low reluctance path? Actually the resistance is nothing but opposition to the flow of current, right? Meanwhile the reluctance is nothing but opposition to the flow of flux. What will be the thing that you are just making up your resistance offered by the circuit to be higher, in the sense you have your flow of electrons to be lesser. Similarly, once you are just making up your construction of circuit, magnetic circuit, by offering your reluctance property to be higher, then you will not be having a proper electromagnetic induction that is being given out by Faraday, will not be happening so. And therefore, once you are just constructing your electrical machine, you want to take up a main point to be considered as the reluctance, that is opposition of flux that is offered by a designing magnetic circuit should be lesser, so that only you will be having a more amount of induction to be happening, which will be a helpful one to have your principle of operation, where you are just placing your windings, that is in case of dynamic and static category of your machines, right? And therefore you can see the words that is being described in your presentation now, how we can create your low reluctance path. Okay, low reluctance path in the sense, reluctance you will be knowing that opposition to the flow of flux. Low in the sense, the property that is being offered by the magnetic circuit to oppose the flux should be low, because in order to have your effective electromagnetic induction to be happening in your magnetic circuit, definitely you want to maintain your reluctance offered by the circuit to be a lower one. Okay, what is the condition to make up your reluctance to be lower? In the sense, it just deals with a parameter called air gap. What is your air gap then? That is nothing but the place that is being present once you are just constructing a machine between your stator and rotor. Okay, stator and rotor. The other name of rotor is armature. Okay, the major thing that is being dealt out here is your air gap. Once you create your low reluctance path, definitely you want to make up this construction of air gap, length should be minimum, and you want to make your area of cross section to be a maximum one. This is the foremost point in order to create your low reluctance path. Okay, the next thing is, you will get into the magnetic circuit concept. You see your diagrammatic representation here, and I am just taking an iron core where I am just winding up a winding over it, that is being called as coil, and formally this is being called as a solenoid setup. Once you are just making up this iron core to be a circumflation, and moreover once you are just making up this coil to be wounded on your circular iron core, that setup is called as solenoid. Okay, and you have your magnetic circuit. Normally it is being created by an MMF, where you will be having up, that is MMF is nothing but magnetomotive force, and you will be having up the flux, that is phi is equal to MMF by reluctance, and you have your representation of MMF as ampere turns 80. The reluctance is being represented as the symbol S. And moreover, this S is nothing but the formula L divided by mu A, where this mu is nothing but the permeability offered by your magnetic material which you are opting for constructing your electrical machine. And this mu is nothing but permeability. It is nothing but the product of relative permeability and the permeability of free space, mu naught into mu r. Once you are considering a medium of air, this mu r to be, that is relative permeability, can be given as 1, and this value changes according to the medium what you are choosing it. And mu naught is nothing but the absolute permeability of free space, and it is a fixed value which is being given as 4 pi into 10 power minus 7 Henry per meter. And the further things that we will be just discussing in your next class. Thank you.